Hello friends, we have seen a Bertrand model of duopoly for heterogeneous product case in my one of the videos, actually one that I posted just before this video, and then there was a long gap before I could make this video. So today we will try to see the homogeneous product case, and this is going to be much more fascinating than the differentiated product model or heterogeneous product model. So you can watch the other one, that differentiated product, at this video. This is my old video. Homogeneous product case, we are going to use Osborne's description as he has given in a book, Introduction to Game Theory. So let's see what the model is about. So there are two forms, 1 and 2, I and J, whatever you want to call it, and then they are selling a homogeneous product, let's say white chalk. Each form faces a constant average cost of production C. So it means the cost of production for a form I, when it's producing a quantity Qi, it's for producing quantity Qi, is given as the average cost multiplied with the quantity. So this also tells me the average cost is constant, so it means the marginal cost will also be constant, and it also indicates that there is no fixed cost of production. Otherwise we would have something before this CQI, but that is not here. It means we do not have any fixed cost of production. Now the demand function is given as A minus P. A is the vertical intercept, so this is our A, and then the slope is negative because the demand function slopes downward, and the condition is this, that price should be less than equal to A, because P is equal to A is the choke price. Nobody is going to buy anything, and if P is greater than A, then forget about how will actually anyone buy. And for P less than A, there will be positive demand, and demand will be 0 if P is greater than A. If my price is here, then nobody is going to buy. And then also C is less than A. So what is C? C is the average cost of production. So this is somewhere passing like this. Otherwise what will happen if my C is suppose here, then what will happen? The average cost of production is this much, and the price I can charge maximum is up to A. So I will be earning losses of this much per unit. So why should I earn losses? So the condition we have to put is C is less than A. So now let's use our trusted friend OneNote to understand this, that how we solve this model. So let's continue solving this model. So first thing that I need to explain is this, that I will be using this particular form. I can simply write that per unit profit when a firm is charging price P can be given as pi is equal to P minus C. So P is the price the firm is charging, and C is the average cost used for producing that particular unit. So that difference is giving me the average profit. If I multiply this with quantity, the total quantity, then I get my total profit. So this will be quantity multiplied with the average profit that I just have, P minus C. So quantity, we have seen that this is saying that quantity is given as A minus P. This was the demand at price P. This was given as A minus P. So that is what we have taken here, multiplied with P minus C. So this is giving me the total profit obtained by any firm. So now comes the interesting part. I can write the profit of firm profit of firm 1 or firm I, whatever you want to call it, when it is charging a price P1, the other firm is charging price P2. So this will be given as this will be P1 minus C into A minus P1, the same form that I have taken there. So this is this part is average profit, this part is the quantity. So if P1 is less than P2, so what does it mean? If the firm 2 is charging a higher price, then my profit will be given with this particular firm. So what is happening here in the market? Both the firms are selling a homogeneous product, that is white chalk. If the other firm charges a higher price, then why should anyone buy from that? They will buy totally from me and I will serve the entire market. Okay, so this is the profit that I will get by serving the entire market. On the other hand, if the other firm and my firm both are charging the same price, then both of us will share the market equally, because both of us are selling the same product. So this will be half of P1 minus C into A minus P1. And in case I am charging a higher price than the other firm, then no wonder my profits will be zero, because nobody will buy from me. Everyone, both the firms are selling the same product, that is the white chalk. So why should anyone bother if I am charging any higher price? Now what happens that when the other firm is giving a particular price, for that price what should be the best price for me or the firm 1? That is what we have to find out. So situation is like this, that if both are charging same price, they will share the market equally. If the other firm is charging a price higher than the average cost of production, then I can actually charge a slightly lower price than the other firm and sell the entire market. Okay, and if the other firm is charging less than the average cost of production, then the other firm is actually earning a negative profit. Best for me will be to avoid selling altogether and earning zero profit. So let's see these things. So what is the best price for firm 1 if firm 2 is charging P2? So what are the cases? One possibility is this: if both firms are charging same price, then market will be shared equally. Firm 1 shares market with firm 2. The other possibility is this, that if firm 2 is charging a price more than the average cost of production, then it is best for me to charge something slightly lesser than firm 2's price, that is P2, and sell the entire market. Firm 1 can sell to the entire market by keeping P1 less than P2, and also you have to keep P1 greater than C. Okay, otherwise you will earn zero profit if you keep equal to C, and if you keep lower than C, then anyway you will earn losses. So if Firm 2 is charging a price that is less than the average cost of production, then God help Firm 2, because it's already earning losses. The best I can do, the Firm 1 can do, is earn zero profit, because if it charges here P1 is equal to P2, that is less than C, then both the firms will share the market equally, and actually they will share the losses equally. So best Firm 1 can do is actually earn zero profit, and it can earn zero profit by charging any epsilon more than P1. Firm 1 must charge P1 greater than P2 so that pi 1 is 0. This is the best Firm 1 can do here. So now we can actually move slowly towards our best response function derivation by plotting the profit functions of the Firm 1 for different situations. So let's do that, and this is very fun activity, so let's do it. So this is the first case. This is here I will have P1, the price of the Firm 1 is going in this direction. This is 0, and this represents pi 1, because I am using 1 and 2, so use pi 1. This is positive in this direction, and if it is below 0, it's negative. Now I can set one where this is A. So if price is more than that, then demand will be 0. So this is A, and then we will also have our C, the average cost of production, and in between that will be the monopoly price. And you know that monopoly price is the best for any firm if it can achieve that price. So now we have to set the price of the other firm P2 somewhere, and try to see what will be the best for the Firm 1 to do. So this is the case where Pj or P2 is less than C. If P2 is less than C, so this is the case P2 less than C. It means my P2 should be somewhere here, anywhere to the left of C. So suppose that this is Firm 2's price P2. Now see what is happening. I am plotting Firm 1's profit function with blue color. So what happens if Firm 1 charges any price less than P2, that will be to the left of P2, this portion, it will earn negative profit. So you will start with a negative profit like this. The moment it charges P1 is equal to P2, then what will happen? Both will share the market equally, and because the Firm 2 was earning losses, Firm 1 will share half of the losses, so the profit will be here, and that's why at that particular price we will have a hollow circle here in the profit function. This point is not included. Immediately my profit is coming to the half of the losses, and beyond that I am just plotting this for the sake that this goes like this. This doesn't matter, because the firm, the moment it charges any P1 that is greater than P2, it will not sell any single unit, so that portion becomes irrelevant. We are just showing that what will be the shape of this. So this is the profit function of the Firm 1, and now we can actually write here, if P2 is less than C, so it means that Firm 2 is actually charging less than the average cost of production and earning losses. So Firm 1 can actually get profit less than 0 if it is charging any P1 that is less than equal to P2. Firm 1's profit will be less than 0 if P1 is less than equal to P2. So you see, P1 less than, that is this portion, you are earning a negative profit, equal to this portion, again you are sharing half of the losses. So both these situation will give you negative profit. And P1 the profit of the firm 1 will be 0 if price of the firm 1 is greater than the price of the firm 2. It means if you are anywhere to the right of P2, you are safe. Why you are safe? Because nobody will buy from you and you will not earn any negative profit. You will just stay with the 0 profit. So let's plot the profit function of the firm 1 here. So I take this particular color, let's say green. So this is like this. See here, this point P2 will not be included. So there is a hollow circle here. It's not a solid disk. So this point is not included. So this is the profit function, the green line. So what does it tell? It tells that any P1 that is greater than P2 is a best response to Pj, because I am earning 0 profit and that is best I can do here. Any P1 greater than P2 is a best response to P2. So we denote it like this: best response of let's not write I because I am using 1. PB, best response of firm 1 for the price of firm 2. This will be given as P1 such that P1 is strictly greater than P2. So this is the best response that we achieved in this situation. I hope you understood the logic that how we are doing this. Now let's see another case, and this is the case when Pj is exactly equal to C. Then what will happen? Not Pj, P2 actually. So this is P1 and this is Pi1. So again let's set our parameters A, C, and this is midway will be Pm. Now let's think about Pj is equal to C. So Pj is here actually. This is Pj. So now what firm 1 can do? If it charges any price Pi or P1 that is less than P2, then definitely it's going to earn losses. So that portion of this profit function will be coming like this. This will materialize. So this is shown with a dark line, solid line, and it will continue. If it charges any price higher than my P2, then this will be like this. So you see that what is happening here? We are having the profit function, the price that it should charge is like this. So now this point will be included, because in this situation the best P1 can do is earn 0 profit. If it charges any price P1 that is less than P2, it will earn negative profit because the price will be lower than the average cost of production. If it charges any price more than the P2, still it will earn 0 profit because nobody will buy from it. So this is the case when P2 is exactly equal to C. So I am writing, if P2 is equal to C, then Best response of firm 1 against price P2 is given as P1 such that P1 is greater than equal to P2. In either conditions it's earning zero profit, so it's indifferent between choosing P1 is equal to P2 or P1 higher than P2. Now what will happen if P2 is actually higher than the average cost of production but less than or equal to PM, that is the monopoly price? What will happen in that situation? So let's see that here. P1. So parameters A, C, PM. So now where is my P2? P2 is higher than C. So let's say P2 is here. Okay. And P2 can be more than or less than or equal to PM. So I am taking a P2 that is less than PM. So any price if I charge less than C, then I will be earning negative profit, the firm 1. But I can start earning positive profit by charging a P1 that is greater than C but less than P2. The moment I reach P2, then I will have a hollow circle here and my profits will immediately drop to this point, abrupt drop. Why is this drop here? Because now P1 is equal to P2 is there and product is homogeneous, so market will be split evenly. So suddenly from being the sole selling profit from selling to sole market, I am getting profit from just half of the market, and then this remaining portion is irrelevant because if I charge my P1 any greater than P2, I will earn zero profit. So this is actually an interesting situation. So this is C is less than P2 is less than equal to PM. So why this is interesting? Because think what is the best firm 1 can do. If it charges any price that is less than P2, it will earn positive profit, but it can increase its profit by increasing its price marginally, by a very small amount. But what should be that small amount? Prices can be infinitely divisible, so I can keep on finding a price that gives me a better profit. So what should I do? This point will not be included because the moment you charge this point price P1 is equal to P2, you are going to share the market equally. So there is actually no best response available to the firm 1 because by charging a P1 that is epsilon less than P2, it gets the entire market and the entire profit, but then how small should be the epsilon? That's the problem. So there is no best response. So I am writing if C is less than P2 is less than equal to PM, firm 1 can increase pi 1 by charging P1 less than P2 but as close to P2 as possible. So in this situation there is no best price, there is no best response because we do not have any best price that can give me the maximum profit. I can always increase my profit by charging slightly lesser than P2 but slightly more than what I was charging earlier. Okay, so firm 1 is in a dilemma. It wants to be as close to P2 as possible, but it has to be slightly lower than the P2 also. So that gives there is no best response. So what we write, B1 P2 will be P1 such that this is phi. There is actually no best response, so this is a null set. Okay, and now the last situation, when form 2 is charging a price that is more than monopoly. This should be actually pretty intuitive to you that what the form 1 should do here. It should simply charge the monopoly price, because form 2 is charging more than the monopoly. So if I charge monopoly, I will be undercutting the form 2, as well as I will be actually selling at the best possible price that is possible for any seller. So see, form 2, suppose that it has its price here, this is P2. So I can simply see, if I charge less than C, then I will earn negative profit. I can keep on increasing my price up to the PM, and I will keep on getting a positive increase in my profits. And if I keep on increasing price and come equal to P2, then again abruptly my profits will drop. So this point will not be included. This will be a hollow circle, and I will get a lower profit. And if I charge anything more than that, then I will not sell, so this part doesn't matter. So we see that the best I can do is actually charging PM, because here I am getting the maximum profit. Beyond this, if I charge my price, then my profits start to fall. So if P2 is greater than PM, then P1 is equal to PM is the unique best response for form 1. So we realize B1 P2 will be simply PM. Now we have seen that how we actually derive our best response functions. So for simplicity and ease of access, let's write all these functions at one place. That is the way we write our best response functions. So B1 P2, so this will be first case. If my P2 is less than C, then P1 such that P1 is strictly greater than P2. I don't want to share your negative profits or losses if P2 is less than C. If P2 is equal to C, then P1 can be anything greater than equal to P2. Doesn't matter, because it will earn zero profit. And it will be phi if this condition is holding, that P2 is greater than C but less than equal to PM, and it will be exactly equal to PM if P2 is greater than PM. So we got all four conditions of our best response function. You can also write the best response function for the form 2. You just need to change places of P1 and P2. Everything else will remain same. I am leaving that as an exercise for you. Now let's plot these best response function and see that are we getting any common intersection area that gives me the Nash equilibrium. So plotting the best response function, this is the part that we need to do now. So this is again fun thing. So let's do that. So see, this is on this axis I am showing P1, on this axis I am showing P2, and there will be one 45-degree line that will be passing like this from here. So that we need for telling that at this particular price, means this is the along this line both P1 and P2 are the same, they are equal. Okay, so we can make this line even less darker. So how to make this? What about this color? Yeah, this color is fine. Okay, oh, it's hardly visible. So yeah, this is fine now. So now let's plot our best response functions. So we will have C at a common portion, means at a common distance, not common portion, because C is same for both the forms. And then we will have PM, the monopoly price. So now see what happens. The first condition of my best response function is if P2 is less than C, P1 should be strictly greater than C. So P2 less than C, it means on this axis I am showing P2. So P2 less than C will actually be somewhere here. In this situation, P1 should be strictly greater than P2. So what does it mean? P1 I am showing along this axis, it should be greater than P2. It means this boundary will not be included, 45-degree line will not be included. So I am drawing my P1 like this. So this will go like this. This 45-degree line is not included, remember this point. So this portion, this entire portion is actually giving me the value where this is P1 greater than P2 if P2 is less than C. Okay, so this is the portion. Now the second part is if P2 is equal to C, P1 can be anything greater than equal to P2. So P2 is equal to C is this. So take a line from like this here. So let's plot this portion now. So this is this. If P2 is equal to C, so P1 can be equal to C. So this point on 45-degree line will be included in the best response function, and the remaining line is showing the remaining portion of the best response function. Okay, so this is so this particular portion is P1 greater than equal to P2 if P2 is equal to C, because the firm is going to earn zero profit anyway. And then we cannot plot this phi thing because I cannot find a point that shows null set. So we will leave this portion, this particular condition. Now we will look at that firm 1 should charge monopoly price if P2 is charging anything greater than monopoly. So now what does it mean? From this PM thing comes somewhere here, right? So firm 1 should charge monopoly price. So this is the monopoly price, and so firm 1 is charging monopoly price, but P2 is not charging monopoly price. So this point will not be included along the 45-degree line. So that's why we have a hollow circle here. Okay, so we successfully plotted all the points. This is P1 is equal to PM if P2 is greater than PM. So we have shown all the 4 conditions, not all the 4, one we cannot actually plot, so that is not shown. Otherwise everything else is shown here. Because the forms are symmetric and all the conditions are same, so we will have symmetric thing for the form 2. So I am leaving that as an exercise for you. I am just plotting it very quickly here. And to make things faster, I am simply making this. This point will again be included because here P2 will be equal to P1 along the 45-degree line, and you can color this remaining portion. And while coloring, if my paint goes beyond the lines, just understand that is a mistake of graphing, means coloring, and that is not a mistake of the plotting part where we are trying to delineate the area. So anything beyond the line, if any color goes beyond line, that is not included in the plot. That's a mistake of hand-eye coordination and coordination between OneNote and my graphic tablet. So this is the portion. As a practice, you may actually think of telling that what is this portion, and now I am telling you this is the portion that P2 will be greater than P1 if P1 is less than C. So see, if P1 is less than C, then for this entire portion P2 should be more than P1. So this boundary will not be included for the same reason. This particular point is P2 is equal to P2 should be greater than equal to P1 if P1 is equal to C. So along this particular line, black line and this solid dot, anywhere form 2 will earn zero profit, so it's indifferent, charging any price. Now comes the final condition that if P1 is greater than PM, the form 2 should charge PM. So that will be here. So let's extend this. Yeah. So now this will again also have a hollow circle because that part will not be included where they are equal. So if P2 is equal to PM if P1 is greater than PM. So now we have plotted our best response functions, and you know that in this graph the only intersection point we are getting is actually this point CC. Other than that, we don't have any common intersection. This area, though it's looking like overlapping in our drawing, it's not overlapping because 45-degree line is not included. This is not an overlap because both the points on the 45-degree line are not included. They are hollow circles. So only common point that is of intersection, that is CC. Only one intersection point, and that is C comma C. So we realize that unique Nash equilibrium of this homogeneous product model by Bertrand is given as CC. And what was C? C was the average unit cost of production. So this is something very interesting. We realize that both forms will charge the unit cost of production. Unit cost of production. And what will be the other equilibrium parameters? So we now know that P star will be C, the average cost, and Q star, the total quantity, will be given as A minus C because the demand was given as dP was given as A minus P. So P is C. So we got this here. And then individual quantity by each form, Q star, Q1 star is equal to Q2 star is equal to A minus C by 2, and the profit will be 0. So what is this? Zero profit and price is equal to average cost is actually long run competitive equilibrium. So now what is this happening? Long run competitive equilibrium. So isn't it actually a paradox? Don't you think? In competitive equilibrium there are small n number of firms which actually drive down the price to the average cost of production in the long run, and profit becomes zero. The same is happening here in the Bertrand model with only two firms, and they are actually reaching the competitive outcome. How this is happening? This particular phenomena is called Bertrand Paradox. That there are only two firms, but only two firms producing competitive outcome. Now there is one thing that you should notice, how actually these two firms are able to produce this paradox. In the competitive market, it was n number of firms which are actually supplying a lot quantity altogether by combining together, and then they are able to drive down the price to average cost of production. In the Bertrand model, if this is to happen, the only possibility is that both the firms should not have any capacity constraint. No capacity constraint is a must for Bertrand paradox to hold. So two conditions which are essential, that they should be producing and selling a homogeneous product, and second, neither of the firms should have any capacity constraint. If there is any capacity constraint, then we will not have this Bertrand paradox and price will not come down to C. Okay. So see here the number of firms are only two, but then this number is being compensated by infinite production capacity of these two firms. Okay, and we get our this particular outcome, P is equal to C. So this was the Bertrand's duopoly with the homogeneous product model. Ask questions if you have any, put in comments. Like, subscribe, and then keep safe. We will meet you again with some new topic on game theory. Take care. If you have any suggestions, give me, and bye.